an AI model that can take its time, think through various responses, and provide a logical answer, and also present its chain of thought. You may be thinking of ChatGPT O1, but the new kid on the block, DeepSeek R1 from China, is free and has surprised everyone. It costs 90% less than the US AI models, and it seems took only $6 million to test the model, whereas OpenAI and other companies have spent billions of dollars. I think most GPU chips are imported from China and Taiwan, assembled in the US, and then exported back with restrictions. But I can be wrong. Let me look at testing the model the way we tested O1 preview without getting into the geopolitical debates. The DeepSeek R1 is designed for advanced thinking, often described as PhD level. We will explore its usage with a series of practical examples that highlight its incredible capabilities. You can access DeepSeek from www.deepseek.com. This is the initial screen. You can get the app or you can directly use it on the browser, which is very similar to ChatGPT interface. Let me use this. You can use the model DeepSeek Think R1. I am on DeepSeek. No need to register. You can just log in with your Google ID like I have done with my Google ID. It says, I am DeepSeek. How can I help you today? The interface is very similar to ChatGPT. Open sidebar, new chart, like that. Let us ask our first question. A merchant has a 40 kg stone that breaks into 4 pieces. With these, he can measure all integral weights from 1 kg to 40 kg using a balance. What are the weights of the 4 pieces? You see that the model is DeepThink R1, so it uses chain of thought prompting. You can even do internet search also. You can attach files as well. Please pardon those birds. Now for this problem, it has taken a lot of time, thought for 134 seconds, that is more than 2 minutes. So it does deep level thinking. So there is a problem about a merchant who has a 40 kg stone that breaks into 4 pieces. First telling me what it understood about the problem. Interesting, I need to figure out what those 4 weights could be. See, it restates the problem. Balance scale, right? So he can place weights on both sides of the scale. That is important to know, because on a scale you can have plus when on one side, and if it is on the other side it becomes negative. Then it goes on to solve the problem 1 to 40. So the object would actually be 5 kg weight. Let me think again. So it keeps rethinking. Continuing the pattern, higher numbers can be measured by combining the weights appropriately. 10 kg can be 9 plus 1. Then it does say weight lot of times as it is keeps thinking. So it says, it seems like using the weights 1, 3, 9, 27 kg allows you to measure any weight from 1 to 40 kg. It doesn't get the mathematical problem that this is a ternary system and can be solved using a ternary system, which actually equivalent to this one where it says new weight is more than double the previous one. Then it says confirm that it can indeed measure up to 40 kg. So it is kind of overthinking. Final answer, the weight of the 4 pieces are 1, 3, 9, 27 kilograms. It summarizes it: understanding the balance scale, power of 3, verification, total weight 1, 3, 9, 27. So it does very deep level thinking. In fact, overthinking, and solves the problem like Owen did. Let us try to develop some code. Develop a JavaScript based interactive tic-tac-toe game played with a computer as one player. Include all the script and CSS in a single HTML file and make the computer capable of thinking at least 3 moves ahead. It took 1 minute 66 seconds. Okay. First, the structure, it needs a board. So it is very loud in its thinking. It shows what it is doing, starting with the HTML, CSS for a 3x3 grid, JavaScript, human clicks a cell, update the game state, and implementing min-max for the gaming algorithm with a recursive function, evaluation function, testing the min-max with depth of 3 might not be sufficient. Okay. But we said minimum 3 moves ahead. So setting the depth of 3 in the min-max call. Then it knows more about the tic-tac-toe game, the optimal strategy as well. And it keeps saying wait whenever it moves to the next step and thinking. So it does a lot of work, very sophisticated indeed. And then the code. You can copy the code, very clean code indeed, very well formatted. Then it shows run HTML, so you can run here itself. It also shows the implementation guidelines, responsive design, smart AI, game features, algorithm details, how to play. You can save the HTML and run it in the browser. And it says AI is nearly unbeatable. Let us run this. This is very beautifully designed. Remember, Owen didn't do such a good job on this board. Let us try. Okay, it says AI wins. That means if it draws, that is also a win for it. Let us restart. Let me try my trick. Okay, it knows how to overcome that also. So it is not easy to beat. Very good job, DeepSeek. Very good job. And very clean and very sophisticated interface. Here is a classic problem from Knuth. In any party, there are at least 2 people with the same number of friends. We will prompt DeepSeek R1 to break this down and prove the assertion. This example will showcase the model's ability to tackle advanced mathematical concepts with ease. Our prompt: prove this assertion. In any party, there are at least 2 people with the same number of friends. Assertion is that no matter how the friendships are arranged, there must be at least 2 people who have exactly the same number of friends at the party. I love this rephrasing our problem as to what it understood about the problem. This is really excellent. N people. Let it produce fully, then I will scroll back. So it has done a thorough analysis. That took less than 1 minute 54 seconds. Then it applies the pigeonhole principle, which is the correct principle to use here. Here the pigeons would be people and the holes would be possible number of friends they can have. Very clear explanation. Wait, that seems like the key point. So the total number of possible distinct friend counts is n minus 1, since 0 and n minus 1 can't both be present. So this is the key point which it understands. And it also verifies with an example. Suppose there are 3 people at a party. Then it gives the summary of the proof using the pigeonhole principle. Assertion, definitions, step 1, step 2, mutual exclusion of extremes. Apply the pigeonhole principle. At least one box must contain at least 2 objects. And an example as well with n equals 4. And conclusion. Very neatly and very sophisticated again. Well done. Next, let us try a simple problem that many AI models have problem with. Counting the number of words in a given prompt or answer. How many words are there in your response to this question? So it thinks whether it is for the previous question or for this question. So it is going on a tangent and it is trying to recreate the previous response and then provide the answer. Let me stop it here and try it in a new chart. How many words are there in your response to this question? It says, but wait, I need to be careful not to include any extra words that might inflate the count. So if I say there are X words in this response, then I need to count the words in that exact sentence. So it does some overthinking. There are 5 words in this response. Lot of thinking and finally it gave the correct response. Wait, no, it is the wrong response. This should be 7 words. This next problem is conceptually simple but mathematically intricate, involving differential equations. It is definitely a PhD level question. Some models get it wrong. I even got an answer once that they would never collide. So how long does it take for 2 objects to collide due to gravity? Let us put DeepSeek R1 to the test. Our prompt: 2 objects in space, each with masses of 1 kg and 10 kg, are 1 kilometer apart. Assuming only their gravitational forces are present, how long will it take for them to collide? Oops, DeepSeek is experiencing high traffic at the moment. Please check back in a little while. So let me try again. 2 objects in space, each with masses of 1 kg and 10 kg, are 1 kilometer apart. Assuming only their gravitational forces are present, how long will it take for them to collide? So it started thinking. So it uses a ready-made formula. Then it also calculates the differential equation. So it does redo. So it gives the summary finally. "41 years. The two objects will collide in approximately 41 years under their mutual gravitational attraction." I actually checked with ChatGPT O1 for the formula, and it thought about 48 seconds and gave the same formula. T equals pi by 2 root 2 square root of r cube by g into m1 plus m2, where g is the gravitational constant. So DeepSeek is on the right path. Who doesn't dream of becoming a billionaire? But first, let us aim to become a millionaire. Let us see if DeepSeek can help devise a swing trading strategy to reach a final goal. I have heard that DeepSeek started off as stock market analyst, and then they did AI as a side project. So let us ask. I have a $5,000 corpus and I want to double it in 3 years using swing trading. I have access to stock prices of 50 quality stocks from the past 10 years. What would be my day-by-day strategy to achieve this goal? So it uses the rule of 72 by 3, that is 24 per year. That is 24% increase per year. %26%. Risk management is crucial. A common rule is to risk only 1 to 2%. Backtest strategies. Every $1 risked, aim for $3 profit. Finally, it has done the analysis and key components of the strategy. Annual target, risk management, strategy focus, day by day, during market hours, post market, weekly, example, critical success factors, risks and mitigation, so it has given the detailed strategy that anybody can follow. And very important thing is risk management. So it's very well done. This is commendable. As a bonus, we will ask it to plan an optimal road trip covering 4 cities. It is a fun yet practical way to see how it considers multiple factors in planning. Plan an optimal trip covering 4 cities of Dallas, Austin, Houston, and San Antonio in the state of Texas, minimizing travel time and costs while including sightseeing. So it checks the optimum route first. City with a major airport, so Dallas and Houston are good options. Car rental. One to 2 days per city. Finally, it gives the optimal 6-day Texas trip. Dallas to Austin to San Antonio to Houston back to Dallas. Day 1, Day 2, Day 3, Day 4. So Riverwalk is included in this. NASA. And also estimated cost per person. Car rental, gas, accommodation, food and attractions. This is really a good planning you do, and you can always ask follow-up questions on this. Good job done by DeepSeek. As you have seen, DeepSeek R1 is not just an AI model, it is a comprehensive thinking assistant capable of solving complex problems, coding games, planning finances, and more. Sometimes it is overthinking and it got one simple problem wrong, but it does good job of rephrasing our question first, coming up with the answer, and then rechecking to make sure the answer is correct. The interface is also very sophisticated. Please comment what you think about it and the examples. Ready to experience it for yourself? Dive into DeepSeek R1 and discover what is possible. It is also open source and cheaper, so it will change how organizations spend on generative AI. Thank you for watching. If you found this video helpful, don't forget to like, share and subscribe for more updates on the latest in AI and technology. See you in the next video.